Every time a new AI model is released, the internet watches the same thing: the demo, the benchmark, the impossible answer appearing on a screen. And for a moment, it feels like the future is weightless. Just software, just code, just intelligence moving through the cloud. But that is only the visible part of the race. The more I look at AI, the more I think the real story is moving underneath it, into buildings, into power, into land, into cooling, into capital. Because before artificial intelligence can answer anything, something physical has to exist. It stops looking like pure software and starts looking like infrastructure. Servers have to run, data centers have to be built, electricity has to arrive, not as an idea, as real power, in a real place, at industrial scale. This is where AI stops looking only like software and starts looking like infrastructure. AI looks digital, but the race is becoming physical. By now, everyone has heard that AI needs a lot of electricity. That part is not hidden anymore. But I think the deeper question is not just how much power does AI consume? The deeper question is, who can get enough power where they need it, fast enough to keep scaling? That is the part that changes the story. The International Energy Agency projects that electricity consumption from data centers could more than double by 2030. In its base case, demand reaches around 945 terawatt hours. That is slightly more electricity than Japan uses today. But I do not think the real point is panic. AI is not going to consume all the world's power. That is not the takeaway. The takeaway is speed. Software can move fast. A model can be updated overnight. A grid cannot. A company can announce a new AI product in a few weeks, but a substation, a transmission line, a power plant, or a data center campus can take years. That time gap is the bottleneck, and bottlenecks change markets. Because when an industry runs into a constraint, value does not always stay where the hype is. It can move sideways toward the suppliers, toward the infrastructure, toward the land, toward the equipment, toward the company solving the boring problem everyone suddenly needs solved. This is where the video becomes useful. Because if power becomes one of the limits of AI, then the opportunity may not sit only inside AI companies. It may sit around them, in the companies that build the grid, in the equipment that moves electricity, in data centers, in cooling, in storage, in nuclear, in land that has access to power. This is not a list of stocks to buy. It is a map of where pressure is moving. And in markets, when pressure moves, capital often follows. But if power becomes scarce, the question is not only who benefits, it is also who pays. The AI company that cannot secure enough capacity, the smaller player that cannot sign billion-dollar power contracts, the local grid that has to absorb new demand, the community that suddenly sees land, water, and electricity become part of a global compute race. That is why electricity is starting to look like the new oil of the AI age. Not because electricity and oil are the same thing, they are not, but because electricity is becoming one of the inputs that decides who can scale, who can build, who can train, who can serve models, who can afford the next layer of compute. A data center is not just a building full of computers. This is the layer nobody gets excited about, but it is the layer everything depends on. And sometimes, that is exactly where the power is. Morgan Stanley has warned that data center developers expect power constraints around 2027 and 2028. And this is why some of them are looking for ways to bring their own power. Not because the grid disappears, but because AI wants power faster than the normal system can always provide it. And when something is hard to get, everyone starts caring about it. That is when it becomes strategic. McKinsey describes the data center build-out as a multi-trillion-dollar infrastructure race. And this is important because the The money is not only going into algorithms, it is going into chips, servers, buildings, cooling systems, power infrastructure, grid connections, and land. AI is becoming a capital expenditure war, and that makes the industry less digital than it looks. The winners may not only be the companies with the smartest models, they may be the ones that can secure the physical layer around the model. Power, compute, land, cooling, capital. These are no longer background details. They are becoming part of the AI race itself. But there is another side to this. Infrastructure is local. Power grids are local. Permits are local. Water is local. Communities are local. A data center may serve a global AI model, but it has to be built somewhere, and somewhere always has limits. Local grids can be strained. Communities can push back. Power prices can change. Permits can slow projects down. Water and cooling can become political. This is why the AI economy cannot move only at software speed. Software wants to scale instantly. Infrastructure has to be built in the real world. That is the hidden tension. AI companies are racing toward the future, but the future needs power lines. So the next phase of artificial intelligence may not be decided only by who builds the best model. It may also be decided by who can power it. And that is why this matters. Not because electricity is just another scary headline, but because it may become one of the clearest ways to understand where the AI economy is really going. Who can scale? Who gets constrained? Who controls the bottleneck? And who has to pay for it? The AI economy is digital. Its limits are physical. And in the next phase of the race, power may decide who gets to scale intelligence.